So let's solve LeetCode 217 contains duplicate problem. So given an integer array nums, we want to return true if any value appears at least twice in the array and return false if every element is distinct. Let's take an example. So if the input nums is equal to 1, 2, 3, 1, it will output true. Why? That's because the element 1 occurs at the indices 0, so this is the 0th index, and then it occurs at index 3, which is essentially the 4th element. So the element 1 is appearing 2 times. So if it's at least 2, we want to return true, right? So it returns true here. For example 2, we have 1, 2, 3, 4. No element is duplicated. Every element here is unique, so it returns false. So yeah, that's the case. And the final one we have is 3 1s, then 2 3s, 4, 3 again, 2, 4, 2. So as we can see, 1 is present 3 times, 3 is present 3 times, 4 is present 2 times, and 2 is present 2 times. Now, even if one element is duplicated, we want to return true. Here, multiple elements are duplicated, so of course we're going to return true, right? So this is what we want to solve. How do you think we're going to solve it? Well, let's draw it out. We have 1, 2, 3, and 1 as an example. This is the case that we are going to look at. We'll find a solution for this case, and then we'll see if we can generalize that to every solution. So first of all, what are we going to do? Well, we can loop through every element that is present in this array, right? So I'll go through 1, 2, 3, and 1 and go over it step by step. So once I'm at 1, so the first iteration of my for loop, I can check for the rest of the elements if they contain 1. If I find 1 in the rest of the elements, then yes, we have a duplicate, so I can return true, correct? The problem with that approach is that I have to loop over all of the elements for the first time, then I have to loop over all of the elements second time. So that's 2 for loops within each other. So I'm first finding out all of the n elements, then I'm finding out all of the n minus 1 elements, right? Because I'm going from 1 till the end of the array. Then I'm going over the second element of the array and finding out rest of the elements. So it's n multiplied by n minus 1, which is n square, and the time complexity is O of n square. And that is a very inefficient solution for this problem because we are doing some duplicated work. Why do we need to go over this array 2 times? If we can just go over this array once and find out what the duplicate elements are. How can we do that? Let's say I create another variable called list. This is just a list that will store all of the elements that we have iterated through. So I put up a for loop, I go over each of the element in this array that's present, and then I find out that, hey, 1 is present here, cool, I'll add it. Then I'll go over 2, cool, I'll add it. 3, cool, I'll add it. The next time I go over first element again, I'll just check in this list, hey, does 1 exist in this list? If 1 exists in this list, then yeah, we're going to return true. Because we've already iterated through 1, it's again present in the end of the array or somewhere in the array, so it's going to return true. There's 2 elements. But the problem with this approach is that we are using one for loop, but then we are also checking for the element in a list. If we check an element in a list, that its time complexity is also O of n. So going over the for loop, that's O of n, and then finding the element within the for loop of whether the element is present in a list or not, that's O of n as well. So the total time complexity becomes O of n square again. And that's not what we want, correct? So what can we do to solve this? A bottleneck is that this is a list. We want to check if an element exists within a particular data structure and that is taking O of n time. Can we reduce this O of n time? The first O of n time when we iterate over the entire array. We have to do that. That is a necessary one, because without going through the entire array, we'll never know if the elements are duplicated. But this O of n can be reduced because we do have a data structure that allows us to check if an element is present or not within O of 1 time, and that is a hash set. So what we can do is, instead of using a list here, I'll just remove everything and I'll just have a hash set here. So what the hash set does is that it will keep track of all of the elements just like the list does, and then we'll check 1 is there, cool. Now is 2 present in this hash set? No, so we can just add it. Is 3 present in this hash set? No, so we can just add it. Is 1 present in this hash set? That is true. So it will return true and we'll get out of the loop. And this is just O of n because we are iterating through the entire for loop. So that's O of n. And then we're also checking if the element exists within hash set, and that is O of 1. So that makes our entire solution O of n in time complexity. And since we're using hash set, the space complexity is going to be O of n as well, because in the worst case scenario, there are no duplicated elements. For example, the example that was given, 1, 2, 3, 4. All of the elements are unique. So what we'll have is a hash set here where we pass in 1, 2, 3, and 4 because, well, we'll just check, right? Is 2 present in the hash set? No, it wasn't when 1 was there. So we just add it. The same goes for 3. The same goes for 4. So this hash set has the same number of elements as this original list. So it's going to be O of n. And that's the space complexity. So that is the solution. You can test it out for this one as well. It's going to be relatively very easy because we iterate through this entire loop. We find that 1 is present. Okay, we add that to the hash set. Then we go to the next one and check, is this one present in hash set? And it is, so we just return true. So yeah, let's code it out really quickly. So we'll have a hash set is equal to a set. This is how I'm creating a set, an empty set. After that, I'll go over all of the elements that are present in the nums array. And for each num, I'll first check if num is in hash set. If the num is in hash set, I want to return true because it contains a duplicate. But if the num in hash set does not exist, then I can just do hash set dot add and then I'll add the num. And then you'll think that we're done, but we're really not. After this entire for loop ends, we can also return false. The reason we can do this is because, let's say 1, 2, 3, 4 was the array. So 1, 2, 3, 4 for all of them, it doesn't return true and it adds all of the elements to the hash set. After that, we get out of the for loop and automatically Python will just return none. And if it returns none, it's going to be invalid first of all because it's Python 3, the type is Boolean. So you can't return that. You probably need to change that to optional Boolean, etc. But the second thing is that we don't want to return none. It should be returned false because there are no duplicate elements. All elements are distinct. And once we do that, it should work out. So I'll just run the solution and accept it. I'll submit it. And it works out as well. Now, one thing to note here is that you cannot put hash set.add here. It should always be after this if condition. The reason you can't put it over here is because, think about it. You're going over 1, 2, 3, 4, for example. So you go over 1, num is 1 in the first iteration. You add it to the hash set, and then you're checking if that num is present in hash set. Yeah, of course it is present in the hash set. You just added it. So obviously you can't do that. You have to do it after the if condition. Just keep that in mind. And that is a very simple solution and the best solution for this problem.